So we'll get started. Good afternoon. My name is Gaiman Yi. I'm the Technical Director of the I4 Energy Center. So welcome again to everyone back from spring break to our Friday seminars. Welcome to those that are on the web. Before we get started today, I do have one announcement. There's going to be on Tuesday, April 5th, from 6 to 8 p.m., there'll be a lecture and also a panel discussion, demystifying the smart grid. Everybody's welcome. Ask a friend to come. The lecture is from 6 to 7, and then there'll be a panel discussion from 7 to 8 p.m. And I was told there'll be some refreshments, so please come. I don't know if anyone knows, there is a California Smart Grid Center up in Sacramento.
Everybody knows.
Yes, everybody knows. At the Cal State Sacramento, and we have two persons from that institution here today. We have Dr. Emir Jose Macari. He's the director of the center. He's also the dean of the College of Engineering and Computer Science. Prior to this, his involvement at Cal State Sacramento, he held faculty and administrative positions in Georgia Tech, LSU, and the University of Texas at Brownsville. In 1993, he was awarded the White House Presidential Faculty Fellowship by President George W.H. Bush, and in 1994, he helped draft the President Bill Clinton's science policy document. Also today, we have Suresh, I hope I pronounced the last name, Vadva. He is the chair of the Electrical and Electronic Engineering Department at Cal State Sacramento, and he's also the Associate Director of the California Smart Grid Center. So welcome both of them, and they're going to be a tag team presentation today. Thank you.
Very good. Thank you. Thank you all very much. It's great to be here on the Berkeley campus. I stayed last night at the Durant Hotel. I had some meetings here on campus talking about earthquake engineering, since we're all pretty aware of what's happening around the world with big events, and obviously the nuclear effects that are happening after that. When I realized that it was going to be on April 1st, my lecture, I started worrying a little bit to see if in fact people were going to show up, or if this was going to be a UC Berkeley April Fool's joke. But I see all of these folks down here in the hallway, and big room filled up. So I thank you all very much for this. What Suresh and I want to talk about today is power and telecommunications engineering in the context of smart grid. Basically, what we know is that these are two different and very distinct disciplines that rarely talk to each other. As a matter of fact, they have very different language, very different challenges. But now, with the onset of smart grid, they are required to speak to each other. So how can we educate a new cadre, a new group of engineers and IT professionals that are going to be able to help us bring this smart grid? So let me start with some general comments. First, the California Smart Grid Center, we created it a couple of years ago. We've been working a lot with CIEE here on your campus. And you folks have been great mentors to us as we started rolling out into our research mission. As you know, the Cal State system is not necessarily known for being a big research system, but all of my academic background, has really been at Research One institutions. So when I came to Sac State 5 years ago, I was surprised, first of all, to see that we didn't have a PhD program. I didn't understand what this difference was between a UC and a CSU, and that our folks didn't do too much research. So I said, well, hold up, we got to start changing that, because that is one of the great pleasures of being in academia. Not only really the involvement in the teaching, which is obviously one of our first missions, but research really involves us with all our graduate students, undergraduate students, in working on areas that are not necessarily well known and are not book type of problems. So you need to be working on innovative solutions, and working with students and faculty is really what it's all about. It's really interesting, and that's the pleasures of academia. So we were able to come up and through Ron Hoffman, who's been a great mentor, Il Padrino, the godfather really for us, helping us come on to work with CIEE. And then we approached the Energy Commission, the Department of Energy, and several industry supporters for funding. We have been very successful at that. And now we have a full-fledged research center. So now we feel like maybe it's not a level playing field, but we can feel we can speak to the UCs head-to-head and be able to bring some value added to you guys. And that's what we're here for today. The mission of the California Smart Grid Center is to engage in product testing. We are not really about basic research, but we want to be able to see what devices are out there, what equipment is out there that is interoperable across the different fields, and be able to showcase it, and if not certify it, at least be able to inform folks about the performance of these devices as they become practical for field solutions of large-scale integration into smart grid. The center also aims to inform the development of real-time pricing in electricity in an unbiased proving ground. Obviously, one of the important aspects of smart grid and all of this smart metering will be the real-time pricing, which is the holy grail at one point, where we know that electricity is not, it doesn't cost the same at every time of the day. However, we are charging people the same amount of cost. If you use electricity at night, it's a lot cheaper than using it at peak hours. So smart meters and the smart grid will be able to really bring that into our train of thought, our consciousness, and people will be able to make decisions about whether you want to pay the premium price to use it at a peak time or whether you would rather use it at other times when it's a lot cheaper. The center also works in support of California's utilities in the development of highly desired upgrades of the electric grid, and one of our big components is workforce development. So that's what we're here for. We've received funding from the Department of Energy to do a California Smart Grid Workforce Development Initiative. We're working with all the major utilities. And also we have some funding from the National Science Foundation to work on cybersecurity aspects of education in smart grid. So I'm not sure exactly what the general audience is here and other places, so just to bring it into the conversation, the smart grid is a generic label for the application of computer intelligence and networking abilities to decade-old electricity. So for many years, really, the electric grid has been very much unchanged. As a matter of fact, it didn't change at all for many, many years, and that's why many research institutions decided, look, this is a mature discipline, and they walked away from power engineering. Microelectronics became the glitzy area, and a lot of people's research went into that area. Power engineering labs, which are expensive to have, you need to have maintenance, there's a lot of risk associated with that, went away from many of our universities, and as such, it was a mature discipline. But suddenly comes in smart grid, and now it is a popular area again, and that is what positioned us at Sacramento State to be able to work in this area. So a major component of the smart grid is also the automation. Smart grid in generalities basically is we have our generation, whether it comes from very traditional generation areas such as natural gas or even coal burning, hydro, nuclear power. Forget that one for right now. We shouldn't even be talking about that one. It's no pun intended, a very hot topic. Wind farms, solar farms, how are we going to be able to integrate all this stuff? But then we generate it, and we go through the transmission, it gets into substations, it gets distributed to the homes, and the homes get out there. Now, the next thing that happens then is that we are going to be having a lot of rooftop solar, and we're going to be having these power electric plug-ins. So how can we work with all these things we need to bring storage. Storage is the biggest problem that we have, both at the substation level, but also in the homes. So we will able to harness what we are able to have during the day in generating the electricity, be able to harness it and use it at any time, whenever it's needed, at peak times or any time of the day. So storage is the big problem right now, and many people are working in the new generation of batteries, both for the cars, for the homes, as the inverters work, how do you store that, but also at the distribution of, and substations. But now, on top of all that, we will have telecommunications. So we will be able to have sensors all around along the distribution and transmission and inside the homes in order to be able to make this grid operation smart. Be able to sense it, control it, and then that will be the reality of the smart grid. However, smart grid is an evolution. It's going to take some time. Today, we are deploying smart meters in some places more than others. Health impact seems to be an issue out here in the Bay Area. We're working on it to demystify that. That is not an issue, but there's still people claiming that it affects their bodily functions, their minds, all sorts of different things. So there is no proof of that, but still people are discussing that. Outage management. Today, the utilities are not able to pinpoint where when your electricity goes down, unless you call and a bunch of other people call. They triangulate it and they try to figure out where it is, and then they send a guy with a flashlight and looking down on a transformer to see if that one's the one that's blown. There is no information out there, so it is a very dumb type of system. So the outage management is going to be a big improvement. Introduce electric cars and plug-in hybrids. They're being introduced, but obviously we don't have the infrastructure. And by the way, the PBS has a really good show. If you go online on PBS, I believe, maybe it's not even Nova, it's just the general group. Click and Clack, the brothers on Car Talk, they do a very nice job of talking about hybrids and other types of alternative energy.
Oh, that was a Nova.
Nova, yeah, it's a Nova, so it's a very nice group. The next thing near term will be empower the users of energy through HANS. I think that may not be the 1 and 2 years that we were thinking of. Actually, we're right now having some discussions that may be pushed back a little bit because there are some issues on the protocols and the types of communication standards that are going to be used. There's some major improvements right now happening that are leaving behind the types of devices that would be used there. In the future, what we want to have is obviously distributed generation and deploy storage system, as we said, all across, not only at the homes, but also in substations. And then finally comes in the automated demand response. So the question was, why Sacramento State? Why not UC Berkeley? And my answer is because we're the perfect choice, not UC Berkeley. We have a great group of people in power engineering. We have a great group of people in cybersecurity and telecommunications, and we have a smaller group, but still very, very important group in renewable generation, renewables principally in solar and solar thermal. So the group works very well. Some of our professors are the writers of a lot of the books that are being used in power engineering, not only in this country, but across the world. And this is just a list of just one of the professors in power engineering, distribution systems, the engineering economy, electrical machines, power systems, and transmission. In addition, we have a Center for Cybersecurity, sanctioned as a Center of Academic Excellence by the National Security Agency and the Department of Homeland Security. So right now we're having discussions with Lawrence Livermore Labs about how to integrate cybersecurity into the smart grid. As we know, we don't want anybody hacking into our smart meters, be able to tell what sort of electricity consumption we're having, especially the people up in Mendocino are having having issues with the federal government coming in and looking at how much electricity use they're having. So cybersecurity has become a major concern. Hacking is something, and we need to do a little bit better plan than what Dilbert's all about. Help screaming is not going to help us. So the President has put out a cybersecurity policy agenda, and the United States deploys smart grid technologies. The federal government must ensure that cybersecurity standards are developed and adopted using these good protocols. It is a major concern right now, not only for the smart grid, but the smart grid is huge, but all sorts of aspects of life. I came into California 5 years ago from Texas. I guess I was a rookie because on my first week here, suddenly I had identity fraud. My credit card started being used to $5,000 at Walmart, $4,000 at a shoe store, and I had no idea what was happening. Fortunately, I'm pretty good at the computer, and we were able to nab these people that were doing this for 2.5 years, and the detective had not been able to capture him. But that alerted me to the fact that we needed to, that this cybersecurity issue was very important. I had been victimized already, and we had to move forward with it. So there are other, the U.S. House Committee on Homeland Security has also stated that cyber security is of major concern and of major interest on, with regard to smart grid. At Sac State, we're working on developing courses and certificates. We have a very large and very well-represented list of courses, both at the undergraduate level as well as graduate level in power engineering, in cybersecurity, working with forensics, internet security, computer attacks and counterattacks, as well as some nice courses in renewable energy. So we're putting together these courses and are going to be offering them online. Suresh is going to be speaking a little bit more about that, and perhaps that would be an opportunity for us to partner with UC and be able to offer some of these courses and then establish research possibilities. We're working very closely, so the California Smart Grid Center has already begun working very closely with all the major utilities, as well as the municipal utilities, which are very large here in California and distributed all around the state. We're working closely with PG&E in a number of areas, Southern California, Edison, San Diego Gas and Electric as well. But our main partner has really been SMUD. SMUD, the Sacramento Municipal Utility District, is right next to our campus, and we partner with them as they approached the Department of Energy seeking funding from the stimulus package. So we were able to secure $130 million, which is helping help Sacramento become a smart city. We're deploying a lot of this infrastructure. Smart meters is one of them, but a lot of SCADA, a lot of different communications. And Sacramento is becoming one of the big smart grid cities in the country. Perhaps the first one, since Boulder really failed at doing that. We work closely with our Power Engineering Society and a lot of industry. They're coming across, they come in and give presentations. We look forward to partnering with all of you. Faculty are invited. We also have a Smart Grid seminar, Smart Grid Center lecture series, and we'd love to invite some of you folks and come and talk and meet our students and perhaps start some further collaboration. These are some of our laboratories, as we were talking a little earlier. Folks that went through power engineering 20 and 30 and 40 years ago come into our laboratories and said, hey, that's the equipment I used. Well, that's the equipment that's being used in many places still today. The thing is that now instead of analog controls, now you're doing digital controls, so you're able to do the interfacing. But the equipment is very similar as before. One of the great things of our campus and of the CSU is that we are helping develop a very diverse and talented pool. As we know, the Latino population is just ballooning here in California. In the Census 2010 really puts in the Latino population at the same level of the majority population, the Anglo population, about 40% each. I'm Mexican. I'm Mexican-American, so I take great pride in actually helping the Latino population. By the way, thank you for having burritos today. It makes me feel at home. So the big question is, can we help create the smart grid? Can we help develop the future generations of engineers and scientists that will help us combat global warming? Because that's one of the big issues. It is to develop these technologies in order to reduce our carbon footprint. And I told President Obama, yes, we can. And of course, in the Mexican way, sí se puede. So with that, I'm going to pass it on to my colleague, Suresh Vadva. I thank you for your attention. And now we're going to get into the nitty-gritty about the types of courses that we're able to offer. So let me quit here and go here. And now go there. And Suresh, let's... This.
Thank you, sir.
All right.
I usually scream, so I don't need to, being a professor, I don't need to have a microphone at all, but since it's webcast, it's necessary right now. My name is Suresh Vadva, and I'm from California State University, Sacramento. And I started there for I wanted to stay in Sacramento for 2 years. And I had black hair at that time, and time passed by. It's 25 years later, and I'm still there. So I've reached a point that probably I will stay there for a little bit longer. So now, one of the programs that we have at Sac State is the power engineering program. Why do we have a power engineering program? UC Berkeley had a power engineering program about 20, 25 years ago. And you still have some of the equipment, but you don't offer it anymore, right? You have seen it probably in the basement somewhere. You're not offering it because the opportunity of receiving research funding is not there anymore. It wasn't there at that time. And so they moved to a different area. One of the reasons that power engineering was scrubbed from majority of the universities was because of attracting faculty. If the faculty cannot produce research grants and receive funding, they will not get promoted and they cannot stay at the university. Fortunately for us, or unfortunately for us, we had quite a few faculty in power engineering, and we didn't know what to do with them. They were not willing to move and change their ideas. They will not move into microelectronics. They will not move into software engineering or into digital systems, microprocessor design. So we kept our power program. And you take the clock forward about 20 years. Here comes Obama with power engineering and smart grid, and we were on the driver's seat at that point. So we have a number of courses in power engineering. Now, the biggest problem that we are facing, even because we have the power engineering program, is hard to attract the faculty again, because everybody else is hiring. There is a shortage of PhDs in power engineering because UCs are not producing any power engineers. Majority of the other universities are not producing power engineers. There's a handful of students in universities that are offering PhD programs in power engineering. Now there is a national consortium to reform the power engineering curriculum. And I'm part of the national consortium. There are about 82 universities joining together through University of Minnesota. We are working on to reform the power engineering curriculum. What they're proposing is, and we are thinking that at the very minimum, 3 courses are necessary in power engineering. Basics of 3 courses, and they said that rest of it, the industry will train them themselves. They can go and work in the power engineering, and the 3 courses are basically a machines course, electromagnetic conversions. The second course is power system analysis, where they talk about faults, one-line diagrams, how the whole grid is structured. And the third one is power electronics. These are the 3 pillars that they say they should have it. Even University of Minnesota, in their undergraduate curriculum, which they have a pretty strong power engineering program, they only offer 3 and maybe 1 or 2 optional courses on top. With our faculty that we have 21 courses that we offer in power engineering right now. just in power engineering, not in any other area. Cybersecurity is separate, forensics is separate, and other courses are separate. So we have a full suite of courses at undergraduate and graduate level. In addition, we have a pretty good sized labs right now, and we are working on 2 additional labs. One is the relay protection lab, and we hope to get it going probably by next year. It will cost close to $1 million or so to put it together, so we are trying to find good sources of funding. Ron, we need your help. Okay, so home area network is another one. This is easier to get. Your local utility will provide us with the home area network. We are in discussions with SMUD right now, which is our utility, municipal utility in Sacramento. Probably we will have a lab within months of the home area network lab. So now, what we have proposed through our federal funding, we proposed a number of projects through the Department of Energy funding, and we received some. We proposed a number of certificate programs, which part of it could be online, which is the beauty of it. So for years, we've been listening to there's a shortage of power engineers. Everywhere you go, the national trend is that all the engineers are older than me. I don't feel old. I'm not planning to retire, but they say all of these guys at age 60 or onwards, they're going to retire. I heard that 5 years ago, and they did not retire. I guess there was a small problem with the economy. I guess all their 401ks were wiped out by the Wall Street sharks. So they didn't retire, but they are going to be retiring pretty soon. So our plan is, if an engineer in San Jose area that is not fully employed, or they want to change fields, we can retrain them. We can retrain them in 7 months to be a power engineer. Okay, so it's just one semester, maybe a summer. That's all it takes to retrain them and to be fully functioning in a power industry. The salaries in the power industry are going up right now. With a master's degree, I'm sure it's peanuts for you guys, but my students are getting close to $80,000 per year for a master's level degree. And they don't have to work in Bay Area. They could work in a remote area somewhere. And the salaries are pretty good size there for them, which is comparable to the salaries that are offered in the microelectronics area or digital area or software engineering area. So, and then we want to provide also advanced level power system. The first level of the certificate program requires some lab. So we are trying to develop a collaborations with Southern California, also multiple universities to provide the labs there, and we will be providing the online courses. And the third type of a certificate is a smart grid certificate, which is very much needed by the industry right now. So in 7 months, we came up with a curriculum that it would be sufficient to provide a complete suite of courses so that they can be fully functioning engineers at the entry level in a utility or a consulting firm. They know things that are necessary. One of the most important parts is that none of the engineers can read prints. If you give them a diagram of all the utility grid, they don't know where it starts, where it ends, what is the lines even looks like. So we put a course in a print reading, maybe it's a 1-unit course. Sasha is looking at it and saying that she agrees, and it's not an easy task. So we also have a course in controls and optimization that's very important now. With the smart grid, it is necessary to go through that. Transmission distribution is almost necessary. Construction standards is very important for us, and power electronics is definitely necessary because power electronics is more important than before because of the integration of renewables. You have solars, and you also have the wind energy that is coming in. Pretty much right now, I think the nuclear energy is going to dwindle down as much as possible. It was getting some legs until this disaster occurred. And relay protection. Protection is most important part of the power systems. So some prerequisites that every university offers that we want them to have before they go into the program. So The level 2 is now advanced, which could be a master's level course, or some of the courses will be master level: relay protection, the power system economics and dispatch, analysis of the fault systems. These are important courses that are necessary at the second level tier. And that could be very much offered through online. And our model of online courses is not just like a course that you guys take. How many of you have received a ticket recently, speeding ticket? Nobody? Couple. Okay. The current speeding ticket, if you take a course, you don't want the points to count on your license. You go and take a course online, which is asynchronous in nature. You take the course, you go and take a test somewhere. You never see any instructors. You never talk to anybody. And if you pass it, or I'm not sure if they grade it even. Maybe possibly they grade it. So they grade it, and then they will put a note on your records that, yes, you passed it, the training course, and after a few months, this ticket will be wiped out. But they will collect the fees from you anyway. So they want to make sure that they increase the revenue. Our model of online courses is divided into three categories. One is the reference material. Second is the lectures. Lectures, we call it information dump. Basically, lecture is one-way knowledge. The students be prepared for the lectures. Then they work on projects with the help of the instructors. So even though the part of the course is online, they must be able to communicate to the professor and other classmates to work on a multi-large project within their community. It might be somebody taking it in New York. Somebody might be taking the course in New Delhi. Somebody might be taking a course in Sacramento or Berkeley. And they will be working on a joint project with the help of the instructor, where the meetings are set for problem-solving portion of it. This model, I think, has been exercised other places, and it works very well. So that's the model that we are proceeding with for certificate programs. Now, these courses, since they're remote in nature, it could be offered anywhere, and it could be taken by anybody at other places. Now, we are in talks with few universities to have a joint PhD program that we will be working with the professors there and ours at the Sac State to have a joint PhD program so that we might be able to manage some of the students with a PhD. Since, according to the California Charter, we are not allowed to have a PhD of our own, but it could be done jointly with another research institution. So there are quite a few power universities that are interested with our background and knowledge that we have to work on a joint PhD program. So Smart Grid certificate is very important now, and what we are proposing in a Smart Grid certificate is a number of courses that are necessary for the practitioners to know more about Smart Grid and also be able to be successful in this area. Future power systems and the Smart Grid. This is basically a course that will talk to them about what are the different type of systems are available now, which is not similar to the current one, where the power is generated at the plant and is consumed at the other end by industry or the homes. But it is distributed all over the place. So we have to talk about how the problems are of the future Smart Grid. Right now, I think the State Assembly has passed a rule for 33% integration of renewables into the grid. 33% means 1/3, right? So it's quite a bit of problem, and it's not just simple. Some politicians say that it's 33%. We have a problem with stability of the power. We have a problem with, what if you have a wind generation and the wind stops? What happens to the power generation at that time from that windmill? It went through full force to nothing, right? So it's imperiodic in nature. Then what about a cloud comes in over the horizon and it covers a solar farm? It covers half of the solar farm. Suddenly now your 20 megawatt system is running at 8 megawatts, because half of it is under the cloud. It still is generating, but it's not generating completely. Now there's a problem. Everybody needs the power, so you have to have an alternate source. You have to look at the storage issue. Maybe you have to integrate the storage into that. And the storage is extremely expensive and also has its own problems. As engineers, what we see is every time there is a problem, there is opportunity for us to do something something productive so that we can solve the problem. And as engineers, also, we create other problems at the same time. So another question is the integration of, that's the distributed generation. Distributed generation means that the power is not generated at one source only or multiple power plants, but it's produced throughout the grid itself. Dean McCarty showed you a picture of the houses have the solar panel, and now there are even talks that even plug-in hybrids could produce the power backwards. That would be about 10, 15 years down the line because nobody is willing to. When I was at the meeting with General Motors, they were not willing to even give the price of the batteries for the Chevy Volt. So there's no reason to give it because we guaranteed the batteries for 10 years. And if they guarantee the batteries for 10 years, they will be reluctant to give the power back to the grid through the batteries of the car itself. So another thing that we are doing, interconnection standards are the biggest problem now. There's a couple of rules that we have worked very hard on them. This is a IEEE Rule 1547 and IEEE Rule 20, and the California Rule 21. But we are looking at other rules. There are some deficiencies in that needs to be corrected. This, on the rules, it's the integration standards. We are working with NREL right now on a research project to look at the rules and also look at the distributed generation there. There's a research grant that is ongoing right now. Microgrids is a big issue. Microgrids means is that you're going to have a self-contained facility that will be working off or on the grid. So if the power goes away, the grid can work on its own. So like there is a hospital in Fresno that is going on right now. There is a project in Borrego Springs from Southern California Edison, is it San Diego Gas and Electric. And also UC San Diego has a small microgrid right now. They are working on it. We have a proposal right now on a microgrid, beginnings of a microgrid with UC Santa Cruz. We are going to work on a project with UC Santa Cruz. We submitted a proposal to NSF for funding to put the sensors and other things at the perimeter of the UC Santa Cruz and look at the parallel processing. They have a generation also there to look at it, how we're going to make a UC Santa Cruz itself a microgrid. It's a great research project and also education process for us. So then automation is the big issue. Not many schools are offering courses in automation. We need to have courses in automation with different variety of computerization that is necessary. In fact, we had a meeting with PG&E last week, and they are very much interested in further automation of their system than what they have right now. And also IBM, which I met with them in Austin like 2 weeks ago, they are interested in working with us on the automation portion of their projects there. So data communications, smart grid data communication. Power engineers don't know how to communicate. Simple. I don't know what about your engineers are. Engineers are hard to communicate, and so for them to talk to the communication engineers is also difficult. So this course is to educate the power engineers how to communicate to the communication engineers so that they can build the future courses for them. So that's another certificate. These will be all online. Right now, we have some funding to produce 1 or 2 of these courses, and we are working with all the utilities to get the additional funding to complete this certificate so that it can be online and produced properly. Okay. Now, some of the workforce development projects that we have received are from the Federal Department of Energy Workforce Development Roadmap that we have. Dr. Dean McCarty mentioned something about it before. about that. We have received a pretty good size funding from the Department of Energy. We have another project through University of Minnesota for reforming the power curriculum throughout the US. It's a conglomerate of 82 different universities that we are working on together. There is another project with California State University, Sacramento, and PG&E on integrated demand side management certificate that I'm working with people at the East Bay and PG&E to put that together. I think the goal is sometime this summer, the courses will be offered, but they won't be online. And the last one, we are working on a $20 million grant with a number of other partners to the Department of Labor. And it is we just submitted our end of it, so there will be others that will be working together on that. So that's coming up very shortly. So hopefully with this, we will be offering our initial certificate program online through that. So on the other parts, we have done a number of research projects. That was teaching. We are working on a number of different research projects also. Our center is a full-fledged center. The first two projects, one of them was building to grid technology evaluation roadmap, which was submetering the Corey Hall. And the first one was modeling and development of load control strategies. These two were with CIEE, and I'd really like to thank Ron Hoffman to get us started. Those two projects were completed, and we are here because of those two projects. And we showed our way that we could do that. As part of it, we got a number of other projects. We got a project from NRail now, where we are going to be also testing within that project the different type of inverters. So we have a demonstration project with Beale Air Force Base, also with CIEE. We have a microgrid integration and renewable and placement of storage. That's at Sac State that we are working on. Power system stability project, we just received funding from Cisco on that one. And smart grid cybersecurity, we are pretty big at it. We have a couple of grants on cybersecurity. One of them is for the education portion, which is $1.2 million. And there are a few other grants that are coming up very shortly on smart grid. And I think that we will be also working jointly with Lawrence Berkeley National Labs for one of the cybersecurity projects. And the last one is the monitoring and investigation of sample electric loads in a microgrid as a subsystem of the future automated distribution networks. It's a mouthful, right? This is the UC Santa Cruz project that we have submitted a proposal. We could not come up with any other name on it. Believe me, we worked on the name, but being engineers, we couldn't come up with a short name that could work and make justice to it. And knowing that people who are reviewing it are engineers also, maybe we will pass. I hope they will not consider the names being long and disqualify us from that. This is with the UC Santa Cruz, and we are working with a number of professors there also. So that if it comes aboard, it's a 2-year project that will be completed in 2013. And that will be a phase 1 of microgrid at UC Santa Cruz. So these are the number of projects we have done on research basis, but this is only a sample. There's few more that we are looking for. By the way, our center is desperately looking for postdocs also. If you're available and you have some background in power systems, we really like to talk to you about that. And if you like to get trained in power systems, we are here to help you also. So, Dean McCarry, you have...
Well, with that, I think that it's time for perhaps a little bit Q&A, and then allow for some final comments.
Yeah. Before we start, I got a quick question. Of the ones that you've shown here, I believe you're involved with the SMUD Hour projects. Can you talk a little bit about your involvement, the center's involvement?
Yeah, we are working directly with SMUD on several portions of that ARA funds. As Suresh mentions, we're right now working on the development of a home area network laboratory. That is part of the requirements that they have as part of this contract. So we are examining different devices, how they're communicating, and helping SMUD develop that laboratory. In addition, we are part of the work with them on the system, the controls, the SCADA. So that is directly integrated with it. And a good portion of the funds that came in from that project came into Sacramento State to establish smart grid within our campus. So we are right now deploying the infrastructure on the campus. We're going to be metering and sub-metering a lot of the different buildings, have sensors and controls. And we are supposed to have a 20% load shed capability as part of our demand response portion of it.
By the way, the Smart Era project is 127.5 million. When I told them 127, they were saying, don't forget the 0.5 million.
That's not all of it goes to Cal State, right?
No. We got about 10 million of that. The project altogether with the matching funds, it was about $310 million.
Okay.
Since you're using distance education,
yes, sir.
I was interested in how you integrate the distance education with the hands-on laboratories which you're building.
Okay. Yes, the distance education is the reason is that the second tier certificate or the smart grid certificate does not require hands-on laboratories. There are simulation softwares that we have suites of them that will be available through cloud to all the participants. But the low end, the only part of it that will be online would be the lectures and the projects. But we are partnering with other institutions throughout California to be part of a laboratories that the students can take there, because the funding will be through California.
And by the way, that is the biggest challenge, really. The hands-on laboratory is, we pride ourselves at Sac State of giving a hands-on experience laboratory for all undergraduate students. We put in a lot of effort and a lot of cost really goes into it. So how can we relay the same experience, the hands-on experience, online? I started working when I was at Georgia Tech. I created a module for virtual laboratories. And at the time, the technology wasn't quite there. This is mid-90s, early 90s. We were still, OpenGL was not really even imported to the PCs. We were working Silicon Graphics machines. But we had a very nice laboratory, and we tested it out because there's a lot of universities that could not afford the same equipment that the major research universities had. So we tested it, offering that virtual environment to a lot of different universities, and then tested the students at all sorts of different universities, some that only had the hands-on, some that had only the virtual, and some that had experienced both levels. And we presented some papers on that. But it is a very challenging question, and anything that you folks may have in that regard would be very welcome by us as we hope to integrate the hands-on experience online.
We have a question in the back.
What kind of work are you doing with the California ISO?
You can answer something.
Go ahead.
Yeah. Yeah, the ISO is part of our advisory board. We have, first of all, a lot of our students are interns at the Cal ISO. So they're very interested in us offering the courses that will help position their students there. They are very interested right now in this issue of integration of renewables. We were just discussing before the seminar started the stability of it. They're very concerned about it, so they're really looking forward to the modeling and simulation that is brought in. So as Suresh mentioned earlier, we are partnering right now with Lawrence Livermore Labs to do a major effort in model and simulation of the entire grid with a lot of granularity in order to be able, because it's going to really require a lot of granularity as all this distributed generation is being integrated. Solar, rooftop solar, farms, the inverter signal that comes out is not the type of signal that is as clean as we would desire. So are we going to have filters? Or what is it that we're going to have? And when that becomes 33% of our generating source, it's going to really bring some challenges to stability. So the Cal ISO, we're working with them on that.
Yeah.
There's another project that we are going to be working with CalISO that we are in beginning discussions of it to take the Intel campus in Folsom, California, and CalISO is next to them, and they have a solar farm also next to it, to put a microgrid around the perimeter. So that would be some of the researchers at CalISO and us to work on it.
And actually, I would encourage the faculty here to organize a tour, a field trip over to the new facilities of the CalISO. It's really outstanding. Their former facilities in Folsom were really impressive. The ones right now are Jetsons, like very, very neat. It's really a Wall Street of electricity, and I would encourage everybody to visit. Yes, sir.
Could you tell me a little bit about the life of after graduation? Their environment is very different from that of the microelectronics or ITs.
I didn't quite catch
the environment for the power engineering you're talking about is different than the microelectronics for the employment. After graduation, I think depends on where you're working, okay? So let's say at the bachelor's level you're talking about, or the bachelor's level. At the microelectronics, let's say a person that works at Intel, for instance. They go in and they should know some architecture courses, they should know some software programming if they're computer engineers or in the digital portion of electrical engineering. They might start working in a validation group. So validation means that they're going to be doing some tasks that they will produce, they work on their education already received. It will take about 3 months of training or less than that to start producing. In power systems, it's about the same amount of time. About 2 or 3 months, they will be able to produce. But with the power courses that we are offering, not just the bare minimum, they will be productive even as they graduate from the program.
Are they going to the more field, like tall tower or somewhere in dark or somewhere in a deep location or whatever?
It depends on the engineering portion. If they might be into substation design, for instance, if they're working for a consulting firm. If they are working at the utility, they might be in operations, and they have to look at the different settings to see how the grid is, stability of the grid. So they can produce very fast there within a few months. But they cannot just start working with 3 courses. They just don't know much. And also with bachelor's degree, I'm not sure, to me, little knowledge is always dangerous. People don't know what their limitations are. So that's why they need to be apprentices and work under guidance of seasoned engineers.
Do we have any more questions? Okay, good. Well, thank you very much, Dr. Kari and Dr.